Hello everybody, I am Professor Turogaball, and today we'll be talking about collisions. There are three types of collisions: elastic, inelastic, and explosion. Now, if you're a dumbass like me, you don't know the difference between these three, and you don't want to consult the diagrams. Today, I'll be explaining the only thing that can keep my neurons firing: explosions. Or rather, explosion collisions. Oh, shut up. You're gonna learn about explosion collisions and you're gonna like it. An explosion collision is kind of like my last divorce. Everything is stationary, then after some sort of event, a rift is split between the two, causing them to go their separate ways. I will always remember you, Sheila. Despite the name, explosion collisions don't actually require an explosion. These are called boring explosion collisions. In reality, an explosion collision occurs when a stationary system breaks apart into two or more fragments. Let's take a look at some examples. Picture this, if you will. Two metal cubes with the same mass are standing stationary on a flat plane. Suddenly, a GBU-57A massive ordnance penetrator missile explodes between them, sending them flying away from each other. Assuming they're the same weight, they move away from the center at the same speed. That is an explosion collision. Let me give you another example. This is a cannon. It is stationary. I hope you are not surprised by this information. After firing, however, the cannonball flies out in front, while the recoil of the shot pushes the cannon back. Make sense? Good. Let's go into an example with some more explanations. I'll also walk you through how to calculate some velocities. This is my ex-wife. Do not ask why she is in space. This fat pig weighs 85 kilograms, and she's holding the briefcase with our divorce papers that weighs about 10 kilos. Now, since she's in the endless cold vacuum of space, she can move by throwing the briefcase. Now, let's say she tosses the briefcase at 20 kilometers per hour. This gives her the momentum needed to fly backwards. This is another example of an explosion collision. But how fast is she moving? First, let's get the variables here. Mass of my ex-wife and the briefcase, along with the initial velocity of the system, which is 0. The velocity of the briefcase is also a variable needed. We first need to convert from kilometers per hour to meters per second. We do 20 kilometers per hour times 1,000 meters over 1 kilometer times 1 hour over 3,600 seconds. After simplifying, we have 50 over 9 meters per second. Let's assign a positive direction to the briefcase and a negative direction to my ex-wife. According to the law of the conservation of momentum, the initial velocity and final velocity are the same, which we can represent with this equation. Now we need to find VFW, velocity final, of my ex-wife. We can rearrange the equation to do that, so now it looks something like this. Plugging in the values, we have this, and after some simple calculations, we have this. We can now move the denominator to the bottom to get this, and after some simplification, we see that my ex-wife is traveling through the cold, dark, endless vacuum of space at negative 0.65 meters per second. We only need the negative to make the previous equation work, so you can drop it as well, giving us 0.65 meters per second. Serves you right, missus, it's not what it looks like. Now I'm going to hand off an example problem to you guys. Let's go back to the cannon. Both the cannon and the cannonball are stationary. The cannon weighs 1,000 pounds to be conservative. The cannonball weighs about 12 pounds. After the cannon fires towards my ex-wife's new house, the cannonball flies at 500 miles per hour. Solve for the speed of the cannon traveling backwards due to the recoil. You don't need to account for friction or air resistance. Pause the video now to solve. You finished with your work? Alright, let's go over the answer. First, the data. Mass of the cannon, the cannonball, and the velocity of the cannonball. Remember, momentum before equals momentum after, which is 0. We'll need to assign a negative value to the cannon's momentum, meaning that 0 equals mc times negative VFC plus mcb times VFCB. After we rearrange to solve for VFC, we get this. Putting in the values gives us this equation, and after solving this and simplifying, we get 6 miles per hour, giving us the answer. Congratulations, you solved an explosion collision. I hope this video helped you out. You better do well on that test, or I'll come and beat the knowledge into you myself. Now, if you'll excuse me, I have an ex-wife to launch cannonballs at.